PreCalc. Everyone walking down the hall knows how to solve this system with matrices because we've done so in class. We write down the augmented matrix 4, 2, 10, 3, 5, 11, and we make diagonals using row operations. We find diagonals along as ones and everything below those ones as zeros. Go back to the original matrix form, the original systems form from the augmented matrix, and back substitute to get your x, y, z, and w. In this one we only have an x and a y unknown. It's quite simple to do by hand, but I want you to be aware of several different ways you can use matrices to solve for unknowns. So I'll set up the basic rule, and this is called Cramer's rule. To use Cramer's rule, you're going to have to come up with the coefficient matrix again, and you're going to have to know how to get the determinant of it. So every matrix that is square has a determinant or a number that's associated with it. So here is just the coefficients. Notice I didn't include the constants. So in Cramer's rule, I'm going to take the coefficients and I'm going to actually find the determinant of it, which I'm going to call D. And notice I don't have my brackets, I have straight lines, which indicates I'm looking for the determinant. The determinant is a number associated with a square matrix, and here's how you get it for a 2 by 2. You take the product of the numbers along this line, and you add the negative of the product of the numbers along this line. So the product of 4 and 5 is 20, and you're going to take the opposite sign of the product along this line and add it to this. So 3 times minus 2 is negative 6. So I'm going to add the opposite of that to 20, and I'm going to get 26. Alright, so this product, 4, negative 2, 3, and let's change that, if you don't mind, before we get too much further. Let's change that to a negative 5 and see if you can tell me the determinant. Because that's what it should have been. Notice I grabbed the wrong coefficient. So back to following the rules for the determinant. Along this line, multiply, I get minus 20, and then I add the negative or the opposite number along this line, and that is minus 6. It becomes a plus 6. So minus 20 plus 6 is a minus 14. That is the determinant. So now, to use Cramer's rule, we're going to solve this system, and we're going to get an x and a y answer. X in the first position, so this is an ordered pair, y in the second. To do that, Mr. Cramer noticed that if you set up this determinant and this determinant, you will get the x value for this system. So let's investigate where these numbers came from. Notice when we're looking for x, in the numerator, the matrix values for x have been replaced. So normally they would have been 4, 3 for this system. Normally I would have grabbed 4, 3, but in the numerator I dropped those and I use the constants. So in the numerator. In the denominator, I use this regular coefficient matrix, and we already did the determinant for that. So in this fraction, on the bottom, I get a negative 14. What's the determinant of the top matrix? When we go this side, we get negative 50, and we go this side, we get negative 22, but I use the opposite of that. So a negative 50 and a positive 22 gives me a negative 28. So now I have a fraction. This line is fraction line. I have negative 28 divided by negative 14, which comes out nice and sweet, and even positive 2. So I'll go up to my ordered pair and put in the 2. Alright, so now let's come up with the y value. And the y value for this, using Cramer's rule, is found. We're going to use the same old coefficient matrix in the bottom. That doesn't change. So we have 4, 3, negative 2, negative 5 again. But the top will change. And it will change the way this one changed. So the y values are now going to take on the constant. So the 4 and the 3, back from the original problem, are repeated, but these negative 2 and negative 5 are going to take on a 10 and 11. So Cramer noticed that this procedure works, and it gets us the correct x and y solution. So when we do the determinant down here, we already did that, it's negative 14. And the top, we get negative 11, positive 44, 4 times 11, and the opposite of 3 times 10, which is a negative 30. So when we have 44 and a negative 30, it comes out to 14. 14 divided by negative 14 is negative 1. So I'm going to go and put that answer in right here. You can check this by putting in x as a 2 and y as a negative 1, and you'll see that it creates a true statement here and here. Alright, so we're going to go on from there and find how to do this with 3 unknowns and 3 equations. So this was 2 by 2. We're going to learn how to do that with a 3 by 3, but we're going to allow our classwork to catch up to us. So just write this down. It's a short and sweet video. And we'll get part 2 of Cramer's rule to come. So we'll see that tomorrow night. Alright, over and out.